In this lab, we're going to build a deck of cards and shuffle them.
You can think of this lab as the beginning of a solitaire game. Listen to the description Zumi gave again, and look for the objects, the things the system needs to use or manage to get the job done.
In this lab, we're going to build a deck of cards and shuffle them.
The things in that description are a deck of cards. That tells us the kinds of object we need, one deck and 52 cards. Let's build the card class first. We need to figure out what cards need to know and what they need to do. We need to know which card each card object is, so we need it to know what its face value and its suit are. That tells us what the instance variables of the card class are. We'll store each of these as integers. For face value, 0 will mean it's an ace, 1 will mean it's a 2, so on up to 10 will mean it's a jack, 11 means it's a queen, and 12 means it's a king. Similarly, we'll store the suit as an integer, with 0 meaning spades, 1 meaning hearts, 2 meaning diamonds, and 3 meaning clubs. So, as an example, the jack of diamonds will have a face value of 10 and a suit of 2. In our code, you can see that there are two instance variables, suit and face value. We know they're instance variables because they're declared outside of any methods. Also note the extra keyword private. This means that only the code in this class can see those variables. Don't worry too much about that right now. We'll talk about that a lot more in stage 5. Our cards need to be able to do 3 things. They need to be able to tell us their face value and their suits, and then we need to give them a good toString method to describe themselves. Here are the methods that we can use to ask a card for its face value and its suit. We'll talk a lot more about toString soon. We've thought about what cards need to know and what they need to do. The next thing to think about is how are we going to create new cards? If we used the default constructor, every card would start with a face value and suit of 0. That would mean that every card would start as the ace of spades. That doesn't really make sense. We'd really like a way to tell a card its face value and suit when we create it, so we need to build our own constructor. We need to tell each card what its face value and suit are, so those are the parameters to our constructor. And since it's a constructor, it will have no return type, and it will be named the same as the class. So here's our card constructor. No return type. The name is the same as the class name. 2 integer parameters where we can pass in the face value and the suit. All of this is comments, starting from the /* and going to the */. They're a special kind of comment we'll learn more about later, but you can see that it helps us document the purpose of each parameter. The body of our constructor just takes each of the parameters and stores them into the appropriate instance variable so that the object will remember it. This example shows how we create a new card. We've declared a variable named C2, whose type is card.
Remember, one of the definitions of class is a new type we are creating. Since we have made a class named card, now we can have variables of that type.
This code would reside outside of our card class. That means the compiler doesn't know how much memory a card needs, so it just allocates a space for a reference. This new statement creates a card. The new statement allocates space for the card object and the instance variables that that object needs. Then it calls the constructor. It passes arguments of 12 and 3 into the parameters, so the parameter v will have a value of 12 and s will have a value of 3. The code inside the constructor will store v and s into the instance variables, so the resulting card will have a face value of 12 and a suit of 3, making it the king of clubs. The new statement will evaluate to a reference to that object, so that's what the assignment statement will store into C2. In order to play with our card and deck classes, we're going to need to build a runnable class named cardRunner.
Remember, a runnable class is one that has a main method. You should be able to recite public static void main string array args.
This main method just creates 2 cards and prints them out. When the system tries to print an object, remember, it calls the object's toString method. At first, the lab doesn't tell you to build one, so the output when you build it will be two lines that start card, @ followed by some gibberish. Not very user-friendly. We'd like the toString to output the face value in the suit. As a first attempt, the lab will have you make the toString just output the numbers first. But that isn't very user-friendly either.
I certainly do not want to have to remember that a 3 means clubs.
Essentially, we need to convert an integer to a string containing the appropriate suit. We're going to do that with an array of strings. We'll call it suit description and declare it like this. It's a constant because we put the modifier final in its declaration. In addition, we've used a new type of declaration that lets us specify the values that are in the array right at its declaration. So this will create an array of 4 strings, and each contains the name of one of the suits. The magic of this comes from how we use it. If we index suit description by 0, we will get the string spades. If we index it by 2, we'll get the string diamonds. So if we index it by the instance variable holding the suit of the current card, we'll get the name of whatever suit our card is supposed to be.
So if the instance variable holds a 3, we get clubs. See the magic? It's remembering that 3 means clubs, so I don't have to.
That is pretty cool. The lab will lead you through a similar conversion for the face value. Eventually, your toString will be smart enough to say things like King of Clubs. Now that we have our card class finished, we can use it to help us build a class holding the entire deck. When we think about the deck, the only thing it needs to know is the cards it holds and what order they're in. It will do that by having an instance variable that is an array of type card. For now, our deck only has to be able to do 2 things. Have a toString that outputs the cards in order, and shuffle the cards. Here is the constructor for our deck class. Don't let it overwhelm you. We'll figure it out. To start, it has no parameters. That tells you that every deck object is going to start out the same. The purpose of the code that it has is to initialize the array of cards that the deck contains. Constructors always start by allocating the space the object needs for its instance variables. This class has just one, named cards, so the object starts out looking like this.
Since cards is an array, it has only allocated enough space for a reference. It doesn't know how many spaces we want that array to have yet.
That's right. The first thing the code in our constructor does is to allocate the space for our array. After that new statement, our object looks like this.
It has created an array with 52 spaces. Since the array is going to hold objects, our cards are objects, those spaces are just big enough to hold references. We're going to need to call the card constructor 52 times to create all the card objects we need.
That's right. And we have to create those objects passing in the right values for suit and face value. Let's think about this a bit at a time. We're going to need to loop through the suits so that we do each one of them. Here's a for loop that does that. The variable suit will start at 0 and get bigger by 1 until it has done all of the suits. For each value of suit, we need to have face value walk from 0 to 12. This loop does that. Since these loops are nested, the face value loop is inside the suit loop. That means we will do the innermost loop for each value of the outer loop. The innermost block is where we're calling the constructor of card. Let's think about the order in which it's going to create the cards.
Be the machine.
As we execute the code, suit starts at 0, and we're going into the outer loop. Then face value starts at 0, and we will create a card with the parameters 0 and 0. We go back to the top of the inner loop, and face value gets incremented. That loop isn't finished, so we create a card with a face value of 1 and a suit of 0. We go back to the top of the inner loop, and face value gets incremented. That loop still isn't finished, so we create a card with a face value of 2 and a suit of 0. And that inner loop keeps going until we create a card with a face value of 12 and a suit of 0. That time, when face value becomes 13, the inner loop will end. That will make us go to the top of the outer loop and increment suit to 1. That loop keeps going, so we start the inner loop over again with face value equal to 0. That will create a card with face value 0 and a suit of 1. The inner loop will run through all the values of face value, creating all 13 cards with a suit of 1. So, each pass through the outer loop causes 13 cards of that suit to get created. The only thing we haven't explained is that variable named position. It starts at 0, and it gets incremented every time we create a card. What it's doing is keeping track of where in the cards array the next card we create should go. That's why the result on the calls on the constructor are stored in card sub position. The first card will go in position 0, the second into position 1, and so on. After the constructor is finished running, this is what we'll have.
The cards have been put into the array in suit order, all 13 of the spades in order, followed by the diamonds, and so on.
Now that we have built a deck, we'd like to be able to output it. Specifically, we'd like the cards to be output to the console in order, with each card on its own line. To do that, we need to build a string that concatenates them all together, and then we can use the special character \n to make the output go to the next line. This toString creates an empty string in the variable s. Then it walks through the cards array. At each position, it concatenates that card and a \n onto s, and stores the result back into s. So, s is getting bigger by each card as we pass through the loop. There's one important thing to notice here. When we concatenate a card onto string, the JVM will call that card's toString method. So all of the work that we did to make the card output nicely will be used here. Once it is built, the deck's toString just has to return that big string, and our output will be beautiful. The last thing we have to do is build a method that shuffles a deck. Shuffling cards is actually an area of computer science research, and there are a lot of algorithms for how to do it. We're using the Fisher-Yates shuffle, and the lab tells you to go to Wikipedia to read about it. That means that you should go to Wikipedia and read about it. Remember, at this point, you don't have to be able to write the code by yourself. After you study it, you just need to be able to explain why the code that the lab gives you matches the description of the Fisher-Yates shuffle you found on Wikipedia. This lab built 3 classes, card and deck, which are instantiable, and card runner, which is runnable. Building card and deck required that we think about what those objects need to know and what they need to do. We built the code a little bit at a time and used card runner to make sure that things worked as we went along. That's a good strategy. If you've only built a little bit since things worked, any bugs you cause will be in that little bit of code and therefore pretty easy to find. If you write a lot of code before you verify that anything works, it will be a lot harder to find the inevitable problems.